Right. So it's currently recording the video. Hopefully it'll generate it at the end of the session, and then I will post them on YouTube. I'll point where the link is for that, and then you can view them again. Okay. So let's go ahead actually and start with, so it's recording, thinking I'm forgetting something. So it's recording and everything should be there. So let's go and take a look at Brightspace first. So, so this is your course 454. And here are the welcome message, the Zoom instructions and everything. So you can take a look at that. Most of the materials will be under content. Okay, so you can see that there. Okay, I've already, oh, and I have already posted the materials for this semester. As you can see, they are posted there. So these are some of the topics and the labs that we will be doing. So I'll talk about that. Also, there's the course website, as you know. So let me open that one.
Pardon me, Professor. A couple people need to be let into the meeting.
Oh, sorry. There we go. All right, so they should be in now. So as I was saying, there's also, so there's going to be the course. So there's going to be two resources, Brightspace, of course, and then also the website here. You just look at this link, so you can see the URL up here, right? And it's 454. This is usually where I just keep my calendar. I've already updated the calendar, so it should be current of what I plan to do. It also includes some videos of last year. So I'll be replacing those with the new videos from this year, but they should still stay in the channel. If if you want to look ahead, you can go ahead and do that. Okay, so here is some of the information, but let's start with the syllabus. Okay, so I posted the syllabus already. Okay, so let's just open it up so that we have a sense. So this course is called ITS 454. It's Assured Systems Design and Implementation. It's technically a network security course. So things related to the network, packet, traffic, etc. And so some of the issues related to that. Okay, so we'll take a look at that. So this is spring 2022. I'm Professor Calix. You can see my information there to contact me. Office hours will be Tuesdays and Thursdays from 4 to 6. So basically before this class, like the period before this class, send me an email and we can, at least for now, use Zoom. The prereqs for this class are the ITS 350 course, the crypto class. This class does not use crypto that much. It's a little bit different focus, but VPNs touch on that a little. So towards the end, I'll kind of combine it. And also 270, your networking class. So a lot of the issues here will involve one or two or more computers. And so, being able to configure simple things in the network should be useful. The book is Computer and Internet Security, a Hands-On Approach by Wang Liandu. So we'll be covering some of the chapters in that book. Okay, and like I said, basically the course is, it's really more, it's a more, assured systems design and implementation. So the goal of this is to look at the design and implementation of an assured system, but the system will pretty much be a network of some kind. Okay, so I'll talk a little bit about that. Let's take a look at the course objectives here. So we will cover network security architectures like the internal network, DMZ, network address translation. Well, we will talk about basically, you know, I always give this analogy when I talk to students. I say, if you're a marine biologist, what do you study? You study the ocean, right? And you study the animals in the ocean. So if you're studying network security, what's your ocean, basically, do you think?
The internet.
The internet, and more specifically, what allows the internet to happen? How is the information sent from point A to point B over the internet? How is it sent?
Routers.
Routers, and what goes through those routers?
Data.
Data, and that data goes in the form of?
Electrical signals.
Which
Packets.
Packets, very good. Packets, right? Network packets. So a lot of this will revolve around this idea of packets, as you will see. We will explore that. Obviously, everything you said was correct. You need some architectures as well. So we will explore, you know, initially what is called sniffing and spoofing. Believe it or not, that's the official terminology for scanning for packets, or if you're which is usually the defense, or if you're attacking a network, spoofing a packet, because it basically, any packet that is not properly or created for a correct goal is a spoof packet. It's a bad packet, right? So that's the idea. So good and bad packets, and that's sniffing and spoofing. We'll talk about attack scenarios, TCP/IP attacks, and then just from, not so that you can attack networks, but just to understand then, you know, what are some of the ways that we can defend against them. We will talk about firewalls and intrusion detections, which are the scanning devices for the network. So we'll talk about firewalls and network attack scenarios, intrusion detections, and of course VPNs. This is where a little bit of encryption will come back in again. So we'll take a look at that. You know, some of those protocols of VPN, and then some of the authentication protocols like AAA, etc. Okay, so that's kind of the idea of the course, and I'll explain that a little bit more later. But that should give you at least a sense that our medium for this entire course is network packets. Okay. And so we want to understand that from the point of view of attacks and defenses. And then, of course, there is the architecture that has to be built, right, for these packets to move around. So we'll think about that more deeply. The course has labs and homework, which are 30% of your grade. Exams are 30% of your grade. There will be probably 3 exams, each one worth 10% of your grade. Usually I do practical exams on this one, although with the pandemic, that's a little bit difficult currently, but we'll see how we adapt. There's a project. Each project, as you can see, is worth 15%. So total project is worth 30%. But I'll talk a little bit about that. There's about this project actually. So we'll see that. So it's 15% and 15%. And then there's always, as I always have, like 10% for quizzes, teamwork, participation, professionalism in the classroom. Basically, if we don't have quizzes, as long as you come to class, you're almost guaranteed to get those points. All right, so that's basically the distribution of the grading. Please read all of these details, read the syllabus. The key thing for me, make sure you submit your homework on Brightspace. Please don't email me any homework. Submit your reports with evidence that you did them right. Okay. So read through this, please. This is the policies and procedures and emergency procedures. Remember, if you're having issues with mental health or COVID-related issues, please contact the Dean of Students. They can help you out. And then these are some of the topics, although we will be looking at these topics, and I have them a little bit here as more general, and I have it more specifically laid out in the calendar itself. Okay. All right, so that should be the syllabus. So are there any questions on the syllabus?
I don't think so.
All right, great. So let's go back to content, just to kind of take a look. So that was the syllabus. This is going to be the module I usually have for project. As you can see, we'll talk about these projects. The projects will be influenced heavily, I have to tell you, based on the pandemic. So if we are back at the campus, there's kind of a way of doing it. If we are here, we're going to have to improvise a little bit. So we will, I need to get further guidance on that one. All right. So that's basically, I'll talk about that. But the first module today is just the introduction, right? So I'm doing an introduction. So this is what is, the security axioms. And basically, it's just a set of PowerPoint slides talking about what is a system. Since the title of the course is Assured Systems Design and Implementation, so there the main noun phrase is system, right? So the main object. So we'll define a system a little bit. There's actually a science called systems engineering out there, which is really important. And so, but this is obviously a security related system. Really, it's related to the network, and it's related to all the, if we're talking about security, as you know, it's related to all the controls that need to be in place to keep that system working and meeting the principles of information assurance, of confidentiality, integrity, availability, and so on. All right, so I'll come back to this, these slides towards the end. As today, I'm just really doing the motivation and kind of lay out the topics. Okay, so let's go ahead and first, since we're done with the syllabus, let's go over to the course website. So let me share that. All right, so this is the course website. You can see, network security axioms and security policies, sniffing and spoofing, TCP/IP network attacks and network security controls, firewalls, intrusion detections, anomaly detections, VPN, and some other authentication services. So that's the bulk of what we are looking at. As far as the topics, we'll be using some of the seed labs, and we'll be doing some of these labs for the course. The videos will be posted on YouTube here on this link. GitHub, if I have any scripts or anything related to the course, I will be posting them on here. Some useful information that might be of use to you. So I usually create this category useful. It usually means questions that I get often from students, right? Several students will usually ask the same question. So, how to get VM workstation, seed Ubuntu pre-built VM, how to get it, how to create a seed VM. I think this is for VMware, if I remember. Yeah, this is for VMware. I have another link for VirtualBox. I guess I need to update that. Here's a video on how to create the seed VM using VMware. Wireshark, we will, of course, as I said, if we're sniffing or spoofing packets, we need to be able to look at them. So we'll look at a lot of tools. We will actually be using, for a lot of the problems, we'll just be using scripting. We'll be using Python and some Python libraries that will allow us to both capture packets and also spoof packets. So we'll take a look at that. Also, if we need to set up VMs as routers, I think this is a video that I have for this. Yeah. So we'll take a look at that. And but we don't have to worry about that right now. So currently, most of the labs can be done in a virtual environment. I've actually done that, when the previous time around during the pandemic, so they can be done. However, they can also be done on physical hardware, right? So there is that duality of it. So the majority of it can be done online. So for now, since it's just like a couple of weeks, we'll see how it goes. But we can do all, we can do the whole class online, obviously. All right. So but like I said, I did get a lot of emails from some of the students about your concerns of being in the classroom. So we'll see how that goes. All right. So as you can see, this is the schedule that's laid out. I've updated it. It's got the videos from last year, pretty much. So this is generally speaking how I plan to go about the course. As you can see, basically, it'll start specifically with just the intro today. What is sniffing the network? We will look at ways of sniffing the network via specific tools or with programming like code. So we'll use C, C++, or we will use Python, something called Scapy, which is a library for Python that is very handy for network related issues, right? So whenever we want to deal with the network, it'll be useful for us. Then we'll look at some TCP/IP attacks. So we will have some tools for attacks. Was that me? Did I do that line? That's interesting. Who did that line? Did you guys see a line? Okay, maybe I'm going crazy. All right. Did you guys see a line? Am I going crazy? No? Okay. Huh. All right. I thought I saw. All right. Because I also saw a name associated with the line, so that's what I found. All right.
I saw a pencil icon here, so I just click and then just draw it. But
you did something, right? How are you able to draw when I
yeah,
have?
I don't know. I saw a pencil icon here. I just click it. I just draw some line, but I don't know.
It's interesting that it's actually interesting that you can draw on something that I'm sharing. I didn't know that was possible.
Sorry, I don't know.
Yeah, it's fine. It's just I'm just saying that's got to be a new Zoom thing because I've never seen that before. Okay. All right. I was just All right. So as I said, so the basic structure is first we look at the network and we understand how we can capture packets, but also generate packets. The whole point of this is to understand. Yeah, we can annotate on the screen, apparently. That's what I'm saying. Okay. So we're going to first start with, how to deal with packets. Then after that, we're going to understand a little bit about attacks. Now, just like in other courses, if you remember maybe your software assurance course, we looked at a class of attacks related to software, right, and the defenses. So here is similar. We are going to look at a new class of attacks and defenses that are related specifically to network packets. Okay, so that's really the key thing that you should understand. It's like a new family of attacks, a new way of doing things that is a little bit more specific to just the mechanics of packets, how they work, etc. Right? So we'll do the sniffing and spoofing, then some TCP/IP attacks, labs and problems. And that basically kind of illustrates attacks. And then, of course, we switch over to defense, and we'll take a look at the various ways of trying to defend the network, right? So intrusion detection systems, as you're familiar with them, firewalls. So we will look at firewalls, IP tables, and and various other things, what are called firewall egress evasion or proxy firewalls. Then we'll look at VPN, a little bit of crypto, some routing issues with VPN, and those are the general ideas of the course. All right. So as I said, everything pretty much centers around network packets. All right. So that's the calendar, and as I said, that's the general sequence that I will follow, but I will be updating the videos, of course. All right, now that we've looked at that, let's kind of go here and take a look at the modules, right? So you can see the modules here. I have them laid out. So usually, after the introduction of this, pre-pandemic era, we would set up a network. So we would set up a network in the lab with the ASAs. It's a little bit more challenging to do that online. However, then after we've set up the network, we run the attacks, run the defenses on the network, and that's kind of how it works. However, the last time I ran this class, I was able to do a lot of this online, and so we will have to just adapt. So basically, these three models that you see here that say ASA intro, ASA practical questions, and ASA radius and Active Directory, this I'm gonna have to move towards the end of the semester when we're back in the classroom, so that we can use the networking equipment in the classroom. Okay. Otherwise, we'll have to adapt to it. But in general, what we would do, or what you should always think about when you're doing your labs, is that you have a network, something like this. All right. So hopefully you guys are seeing this. And so the basic idea is we want to think not just of a machine as an island. Okay. So we don't want to think of a machine as an island here, but instead we want to think of a system as a bigger picture, okay? So if you think about it, this is a very simple network. It's got basically just, our firewalls are called the ASA, so don't mind like the names. This is just a diagram that I always set up, but it's a different model of firewall that we have in the lab. But basically we would have a firewall here, a router here, some switches, and then computers and individual networks, okay? So the idea being that we want to secure, right? So we explore an idea called domains of trust, which basically means with domains of trust that we have areas, networks in our site that are more trusted than others, right? And so we lay out, I don't know how you guys did the writing on this, but I can't. All right. So, so what this means is, for instance, what's behind the firewall here, switch 1, is an internal network. So this would be inside the company, right? And then this router over here is the perimeter router. On the top of the screen, oh, yeah. Ah, there you go. Great, thank you. All right, so on switch 1, this one over here, this would represent the internal network. So basically, that's the internal network. That's the most secure, most trusted, right? This is where all your employees are located. Somewhere in here might be like a data center, etc. But you have a firewall protecting, and that has certain services. This is the perimeter router. So that's basically the outside, the internet. So you can see that that's why this has a little bubble. So that's basically the web, the internet. So this switch 3, anything on there basically represents the switch. And then this area here in between the two devices, this is a traditional, like, you know, manual or static DMZ. And what that means is that here, this is somewhat between the firewall and the router. You can see it's another network, 192.168.1. Excuse me. This switch 2 means that this computer is in a slightly less trusted environment, but it's not on the internet. So if you think about what's the controls, so now everything that we are concerned about is a packet. Some packets are good, some packets are bad, right? That's it, at least for the purposes of this class. And so therefore, what we need to do is we need to, you know, control these packets at these devices, whether at the firewall or at the router. Okay, guys? Now, the difference between both of these, so what is a firewall and a router, right? Well, technically, they're just a sniffer. At the end of the day, they're hardware. The hardware has what? Firmware. What is firmware? It's basically a program, software, right? And so that program will need to use a library. As it turns out, it uses the libpcap library from C++. So that's one of the things that we're going to learn in the course. That's why we look at C a little bit, because that library, the libpcap library in C, you know that C, C++ is a very efficient programming language. And so that one allows you to develop fast applications. So a lot of the things like Wireshark, TCP dump, Scapy, they're built on top of that library. So the router and the firewall are nothing more than sniffers that grab packets as they go through, and they're going to split them into the headers and take a look at them, right? Now, the firewall will, of course, have more security services. So they have, for instance, integrated VPN, you know, those kinds of things, okay? So that's why all of this is important as we will be exploring the course. So if we think about our network here, the only difference between this network and that network is really the rules that we have in here, right? The rules. And they're really just if statements. These are usually referred to as the access control lists or ACLs. And the PICs, or sorry, the firewall here, disregard the name, the firewall here will, you know, let's say it's a Cisco device, but it could be IP tables as well from Linux. It could be from a Raspberry Pi, etc. So we actually have all that hardware in the lab. And so in theory, we could build any network that we want, but this would be the basic thing that we want to do. So then we have to think about considering these domains of trust, right? You know, where this is the least secure, this is the most secure. We would want to think of, you know, what defenses need to be in place considering these attacks. So obviously, that's why one of the things we will explore is attacks. We will start there at the network, just kind of get a feel for that. And then we're going to get a feel for, okay, these sniffers, what do they do? So they have rules. And then what other devices can we put in place to provide even more security services? All right, so that's generally speaking the approach. So you will usually see me refer back to this diagram a lot, just because it kind of allows me to put things into perspective. And really, as I said, at the end of the day, the thing that's key is these domains of trust, okay? What's more trusted, less trusted, because that will determine. So for instance, what's really the difference between this firewall and this router? The difference is that there's more ports open here, right? So for instance, if this is a web server on port 80 has to be open on this router so that from the outside you can access this web server. However, when somebody from the outside gets to the firewall, they will not be able to get past it because the firewall will have some rules as to what it allows. It doesn't like to allow anything from the outside that initiated on the outside. Okay, so that's kind of the idea here. Okay, and so we will explore this. And hopefully if we go back to the classroom, then we have Cisco equipment there. So part of it will be also to configure the devices to build a network and then to run some of the attacks. But the attacks at the end of the day, you know, can be done on a VM. Now, another alternative that we might have is, although we don't need the entire network sometimes, right? So students, sometimes it takes them a long time to realize that a lot of the problems don't require the entire network. Like if you were doing an attack, let's say for the sake of argument, something related to the network that has to initiate here and get all the way there, yes, we would need the entire network built. But some of the time we can just build segments and that's enough for the network. So that's why, for instance, one of the links was how to configure a VM as a router, right? So I have that, I hope it's a video. And so in that case, really, what is that? You configure a VM to act as this, right? And then we're gonna have basically just the two networks. And so any attacks or defenses that we explore will be just on this segment. Does this make sense, guys?
Yep.
All right, great. So that's the general idea, okay? But I usually like to just kind of frame it. I always like framing things within this network because it gives us a little bit more context. Also, placement is important. It's also important to configure, okay, well, if I'm putting an IDS here and I'm attacking from over here, which is, you know, likely, you know, remember that there's some ACLs here already. So there's got to be some filtering going on. So we got to consider some of those aspects. Okay, great. So anyway, so as I said, the documents that say ASA, let's go back. ASA, by the way, stands for Advanced Security Appliance, I think. Let me. Okay, I'm back here. All right, great. That's a nice feature. This did not exist before. So that's a nice feature of it's a nice feature of Zoom. At least I had never used it. All right, so as I said, today, towards the end of class, I'll go over these. These are just very basic slides. But everything under with the heading ASA, so ASA intro, practical questions, and radius and AD kind of relates to building that physical network. Okay, so you can see that there's the document here on, you know, the diagram I just showed. There's also, I have some documents here of, basically, this is not a tutorial, but a guideline on how to do the configuration of it. So that student, it's not really exactly how you do it, but it's a general guideline for Cisco, but not for the devices that we have in the classroom, I guess. So it's different. And then I have some slides here also on like commands, but since we're not technically doing that right away, I'm just gonna skip that for now. And then we have to wait and see what happens. Okay. So then there's these questions. These are related to the problems that we would do. Some examples of ACLs. And then some examples of like VPN, etc. Some of this disregard that, so we'll update. But for now, I'm just going to move these actually so it's not confusing. And then we'll just wait and see. Now, another option is, I don't know that we can do this, but another option is, and I'm not saying you guys have to do it, but if some of you like working together in like little groups, because this class does, it used to be that this class was very group oriented. Okay, that's another part of it. So we'll probably still maintain that, although you'd have to work online, I guess. If you want to work in little groups that are self-contained, maybe, we have some Raspberry Pis that can also be converted into routers. And so if you would like to explore that, they have basically two network interfaces. And so we can basically make that a router or a firewall with IP tables. So that's certainly another option that would allow us to be a little bit more mobile. But as I said, there is a way to make the VMs routers. I think I've only tested that in VMware, however, not in VirtualBox. So it might require for us to convert our, let's just say C2004 into the VMware version. Okay, guys? So we'll just have to adapt a little, but we don't need to do all that right now. All right, are there any questions? So I moved these three ASA just to the end. We'll come back to them. In the first few labs, we're not really needing that much of a network. So because we're just learning what packets are, how to sniff and spoof, and that can be easily done with just one machine. Are there any questions so far?
I don't have any.
All right, so that's the. All right, great. All right, so that's kind of the idea. I just want you to know what to expect. So the two main topics this week are these two, the slides and then Scapy. I'm just going to introduce the Scapy library, do a few examples, I guess, or discussion. It's also well explained in your book, so you can take a look there. And then we'll start getting into some of the labs, sniffing and spoofing. Then, as you can see, the attacks. Then you will look at some of the defenses, and and go from there. All right, so let's start then with the security axioms, I guess. We'll start in the just kind of the layout, some of the theory. So let's start here. All right, so let's start with network security axioms, right? And these are just kind of like pillars also of network security in a sense, right? Although we are building on top of the pillars of information assurance. So if you remember, we had 5 of those at least, right? So confidentiality, integrity, availability, non-repudiation, and authentication, right? So those are the things that we define. And so those are still very much applicable. They're the goals that we want to maintain for our network. But now we're just going to look at this idea of what is a network, right? What is a system? A system is components that work together. And then a network, of course, is kind of the same thing, set of components that work together. So, and then we can look at, an assured system and the design and implementation of it. Okay, so I talked about that. All right, so some realizations when implementing in a short system design. So basically, system security is hard. You might find that some technologies are not appropriate for the threat. You might realize that you don't understand the specific threats, right? So that might be one of the issues. So what are the threats? And so kind of the goal of this course is to look, that's why to look at network data and start to think in terms of the underlying element, right, that causes the problems. So before implementing or designing, you need to follow some rules or axioms. These are basically principles that will allow you to better design and implement your system. And they're actually, this is not meant to be very hard. It's very simple, very intuitive ideas, but it gives us a starting point. So first of all, what is an axiom? So these are ground rules, design principles or considerations or guidelines that are broad enough to apply to all areas of a short system design. So a thorough understanding of these axioms of network security will help you understand how to approach designing your secure system. And at the end of the day, the system that I showed you before, it's kind of very simple, but you know, a good starting point, right? So we have a firewall, we have a router, we have our designated DMZ, and then these are switches, right? And then, as you saw, we have a distribution of networks, different network IDs. And then we talked about domains of trust and what is the internal network. And then, you know, towards the outer network, maybe the very insecure, you know, internet versus the internal network. So this is really, you know, obviously, as you get bigger, it's going to get more complex, but in essence, in general, this is a very simple, but a starting point for a secure system. So some of the axioms: network security is a system, right? So that's one of the first things. So it is not an IDS, nor a firewall, nor a VPN, nor any individual product or technology. It is not your authentication, authorization, and accounting protocol or system. Instead, it is a collection of network-connected devices, technologies, best practices that work in complementary ways to provide security to your information assets. So network security is a system, so you need to focus on the technology, people, and operations, because a change in any one of these areas could result in the need for change in other areas. And it all starts with a security policy. Okay, so if you remember in 350, we talked about the risk and control matrix, right? Where you create, where you identify a set of assets, you identify the threats to those assets, and then the controls. And then you start from there elaborating a security policy, right, of what you want in your network. And then, of course, you have a network architecture, and then you look at the problems that could arise in some of the defenses, which are, as stated here, it's a focus of technology, people, and operations. So implement complementary system elements to counter a given threat. So what that means is that you don't just have like one thing to fight against an attack, you would have multiple things. So you deal with broad categories of attacks also, rather than specific ones. Okay, so you deal with that. For a true security system, you need complementary technology that applies to a specific threat pattern, sometimes called defense in depth. Okay, so basically you have multiple things fighting, you know, the problem. We've talked about threats and controls, obviously, so you must identify the threats to the network. So as I said, in this course, we will look at a new class of attacks that are specific to just packets. And usually I would, if I was to give them a name, I would call them spoofing threats, right? So basically it implies you take a packet, you modify it to achieve a goal. So you're really, what you're trying to exploit is the vulnerabilities in the network protocols themselves, okay? You're trying to, exploit those vulnerabilities. So obviously you also determine the risk of the threat, quantify the impact, and then determine the controls that should be appropriate to mitigate this threat. And then this is just an example of some of the threats. And if you have a threat, what are some of the defense in-depth controls? So if you have port 80 worms, right, like we saw in 450, for instance, where you remember that JavaScript injection that created a worm, some controls to deal with that is a properly configured firewall, right? So obviously if port 80 should not be allowed, it should be blocked. Having a DMZ, which is what I gave you the example, don't have the web server in your internal network. Have a separate DMZ, which is less trusted. Then other solutions like network intrusion detection systems, host intrusion detection systems, antivirus software of some kind, etc. Specific solutions like the ones we saw for computer worms, right? Good practices such as patching. Obviously, this just has to do with like regular sysadmin work, regular vulnerability scanning, as you guys, that pen testing, operating system lockdown, closing ports if they don't need to be open, etc. Right? So this is an example of defense in depth for a specific threat, right? So we have, multiple controls in place. So that's the general idea of what we will be discussing in this course. So you can see also, I should stress, some of these solutions are an actual thing, like this is technology that's running, literally software. This is not software running, correct? This is just network layout or network separation by creating different networks. So you have a network for the internal network, a DMZ network, the outside network. And so that's basically just, how you organize your network and your domains and your IP ranges. And then this is just example of like an administrator doing this kind of work. So they're performing tasks to, like updating the systems regularly to make sure that they're not vulnerable to things. Any questions so far, guys? Nope. All right. So, so how can we measure system effectiveness? So as with everything in life, every system, we need to measure the effectiveness. And usually it's very difficult to quantify how good our system is, right? That's one of the challenges. So usually you can calculate probabilities and try to do that. Now, basically the suggestion that the more complementary system elements you have in place to counter a given threat, the greater the likelihood that the threat will be neutralized. So yeah, maybe, but is this true? So it depends, right? So that's where defense in depth, this idea comes in again. The more you have in there, hopefully the more protected you are in the network. But quantifying, how can we measure the effectiveness? It's certainly a challenge to deal with. The reliability, right? So the reliability of our system and how we measure that in a way is really important. So in system security, there are basically, we'll talk about this, there are known threats, new emerging threats, and totally unknown threats, right? So known threats are like, they've been studied, and then, then you come up with a defense. Unknown threats, sometimes called zero-day type of attacks, etc. Obviously, you've never seen them, so you don't have a defense in place. So how do you deal with them, right? So in a lot of these, we will look at tools, tools that everyone is trying to use nowadays to protect against all of this, okay? Now, is full security achievable? Probably not, but you can help to minimize the risk. That's kind of the approach that you take. It's kind of critical. Design the system to deal with broad categories. That's a recommendation of attacks rather than specific ones. Why would this be better? Anyone? Everybody? Everyone fell asleep? All right, so the idea is, for instance, Snort, as we will see, one of the intrusion detections, or the Cisco intrusion detection systems, they will have, we've talked about this in 350 a little bit already, signatures, right? So they'll have signatures. Those are specific things. There's a specific type of packet that has a specific thing in it. Boom, we have a signature for it. But if there's a variant from that, it's almost like the pandemic, right? With COVID and the vaccines, similar idea. So we need a broad one. And wouldn't it be great if we had a vaccine that covered all the variants, right? So it's the same thing, right? So that's exactly the same idea there. Actually, I will say this, and I don't know if you guys have thought about it, but the pandemic is actually a very good example, a very good analogy of the problems with information, with security, right, of cybersecurity. Because, you think you come up with something and then you put in the vaccines, and the vaccines are like the ACLs in the network that stop things, and then you have like social distancing and all those things, and then boom. You have a new variant, it escapes, and then you have chaos, and you think you've protected a little, and then goes out of control. So it's a good analogy, actually, of the complexity of dealing with systems. And the internet, of course, is a really big system. Okay. Number 2 of the axioms of network security. So number 2, it's going to be business priorities must come first. And so that just means that, at the end of the day, the business needs to do the thing that it does, right? So security will come a little bit second, because if the business can't do its, can't make money, it's going to go out of business. So you can see that there, business priorities should feed into the security policy, which should feed into the security design. Number 3, network security promotes good network design. And what that means is that you should not think of, okay, let's build a network first, and then let's think about how do we secure it. Instead, you should kind of think of both things at the same time, or be mindful of it from the very beginning. So that's kind of like saying, do the risk and control, do your RCM first, right? Do the RCM first, identify the assets, identify the threats, controls. Once you have that in place, make sure you read through that before you design the network, because certain assets are more important than others, right? And that's going to determine where the bulk of the network should be, etc. That's a good example. This is just a graph example of, kind of the same idea, right? So instead of having this network like this, your data center should be behind some kind of a firewall, right? That's the asset that you want to protect. Therefore, you have placement of some device there. Performance issues are also important. Don't forget that the more rules you have, the more scanning you have in your devices, in your routers, etc., firewalls, you're going to slow down the network, right? And slowing down the network is a problem. So that's actually one of the limitations sometimes. And that's why intrusion detection systems, which may analyze more, cannot basically be like in line. They have to be offline because they would slow down the network too much. That also depends on the amount of money you're willing to spend on computing power, etc. Everything is a target, so networks are interdependent. So this makes them both versatile and volatile. So remember, a computer inside your network, if it gets breached somehow, can become the thing that attacks. It starts generating a whole bunch of packets, etc. So you don't need to attack a target directly in order to severely impact a network. All right, so kind of like, you know, everything, you should consider everything to be a target, and that's why you have a you know, set of rules and policies for that. Everything is a weapon also, which is what I said. So an attacker can convert any device into a weapon, something that's gonna spoof packets and just generate more problems for you. One good recommendation that I always like is strive for operational simplicity. Don't try something called security through obscurity. For instance, it would be a bad idea to start changing all the port numbers, right? So if port 80 is usually for web, don't make it port 150 that's going to be now for web, and because then it just makes it harder for you to maintain that network. So keep it simple. That's usually a recommendation. Security should be simple to deploy and straightforward to maintain, okay? And so that usually falls under that idea of security through obscurity. You want to avoid using that. Instead, instead of saying, oh, I'm not going to tell you what the encryption scheme is, you say, here's the encryption scheme, but I know that it works really well. So I'm not concerned. I'm keeping the key, the shared secret, and so I'm not concerned. Okay, so we'll skip this. Good network security is predictable. So your security is only as good as or as useful as you design and configure it. You need to understand the role of each technology in your system and its limitations. Okay. And what other technologies guard against the same threat? So primary goal, understand the strengths and weaknesses of your security system, right? And so that's kind of the idea, to kind of explore that in depth, okay? So to establish a predictable network, make sure you understand the activity and events. So, monitoring the network, right? Having some tool to make sense of all the packets. That's the problem. There's so many packets, right? How do you deal with these packets? All right. And so one of the things we'll talk about later in the semester is tools for that, monitoring this network, making sense of it, in some way. And, it's really impossible. I mean, to look at all these packets and have a sense. So the best thing sometimes, the simplest approach is just to take all this traffic, kind of group it into little groups, and then within these groups, kind of like rank what you see so that you can at least highlight things of concern. There might be some things that are more anomalous than others. So the more anomalous ones can surface to the top, like bubbles in the ocean, right? So imagine your network is an ocean. You want a system that gets certain bubbles to rise up, right? And that's probably the best thing that you can do with something as complex as this. Yeah, consider how to mitigate these attacks, build fault tolerance, and of course, simulation can be good. Simulating things that can happen in your network. Just to see, you can try out things, right? So in the network, how it responds to certain attacks, maybe, etc. I just said this, avoid security through obscurity. So I gave the example of the port numbers. So attempt to make sure your design is indifferent to what others know about it, right? Keep system design and device selection confidential, sure. And this is true. Most companies will not give you their network design, their specifics of it. But, you know, from the point of view of maintaining it, you know, changing default ports probably introduces more complexity and confusion and time spent modifying applications than really the value that you will get out of it. So this is certainly not recommended, generally speaking. And then we have confidentiality and security are not the same, right? So confidentiality, as you know, is a principle protecting the information that is not disclosed, whereas security is a protection of systems, resources, and information from unintended and unauthorized access or misuse. So security is a superset of confidentiality because it goes beyond protecting information by also protecting system functions, you know, availability, for instance, etc. And this one preventing their inappropriate use, that would be non-repudiation, most likely. All right, so this kind of takes us to the, you know, what you guys know, right? The security goals or the pillars of information assurance. So I've mentioned this. I'm not going to review this because we cover it in a lot of detail in 350. So I'm pretty sure you guys know what we're talking about. So you can just read through this stuff. That will be helpful. Now, as you can see, the axioms are important. We mentioned 9 of them. They're simple things. They provide some guidance. But you must remember that security systems have trade-offs. Adding encryption can make antivirus scanning useless with data that's encrypted. So remember, this is a big issue, right? When you have encrypted data, what do you do, right? You know, it's an issue. How do you apply security mechanisms to encrypted data? By definition, encrypted data should be random, right? Or, you know, the goal of it is for that data to be random. So in theory, you're wasting your time. You know, at least for the standard encryption algorithms, there are some encryption algorithms that are meant to create encrypted data that can still be processed while it's encrypted. That's called homomorphic encryption. But that's not, you know, that's special cases, basically. But at the same time, of course, you're not going to send confidential data without encryption. So we will have to, you know, again, these are things that are considerations. You know, where's the data going through the encrypted channel, like a VPN, and then where do you place your devices? You know, what's the point of placing an IDS, patching, you know, tapping it into a line that's where all the data is encrypted, unless you have some kind of special software that's made to deal with that. So anyway, those are some conclusions. So basically now a little bit of security views, just how do we look? Remember, again, this course touches on systems in general. So I will be coming back to the term system every so often, given that, you know, you guys are not systems engineers, but if you're ever involved with a network is a system, so it behaves like a system. Therefore, the laws of systems or the rules of systems would apply to it. So some of the security views. So security is a system. A system can have many subsystems, as you know, right? If you like, you know, this is where you can imagine you're like zooming in, right? You're zooming in into a view and to get a deeper view. So a system can have many subsystems, and security can be viewed from many scales, right? So for instance, here we have the network scale. This is an abstract view. These are all for Ben Sorn, by the way. So we can look at it definitely from this view, right? We just have Joe, Joe's got a client machine, right? And then there's some kind of internet connection and then a server, like when you're doing e-commerce. And that's a view, but we're not actually getting into the details of the internet, right? Although things are happening, obviously, there. So we may just focus here, right? And that's it, because we probably can't control that unless this is your own company. So that's a security view. Now we can take that and blow it up, zoom in. Now we have, basically a lot of devices, the internet basically, or if it's your internal company, also your layout of devices, DNS, and then routers and the ISP servers, streaming media, and so on. Okay, so you can see how this just means it's an expanded view of the network scale. If it's an internal network, more issues to worry about as the packets are traversing. We can also have a single computer scale, and what that means is when you're just worried, remember, just from the point of view of the network, you're just worried, or packets, you're just worried about one single host machine. So in this case, for instance, we have an operating, so single computer scale, right? So single computer scale. We have the operating system, and the operating system then has, device drivers, etc., that allow it to connect to the network, right? So then, and then on top of the operating system, what is usually called, the kernel, etc., you have other things, right? So other applications that run on it, right? So we can think of it in that scale as well. Now, this scale we won't really take a look at so much, but this is the low-level program scale, assembly scale, right? So you guys have looked at this a little bit with the buffer overflow labs, and this can get even lower. But we could look at that scale, right? So that's almost not in the network anymore, but just in the specifics of the operating system. So it's certainly another scale. CPU scale, a lot of the electrical engineering, ECE people will look at that. That's just basically issues related to security at a scale of the microchip, etc. And so on, right? So that's just, the point is kind of like what I said initially, right? So this idea of the system views, I'm going to change over here to the original document. And you can see here, if we go to this, not open. You guys see it? So if we look at this document here, you can see it's the same thing, right? So what is the appropriate view that we are looking at? Okay, so the appropriate view is the entire view, specific network segments, a combination of network segments, a host, a device, etc. Right? So that's kind of what that implies is what, what are you looking at in your individual aspects of the network. All right, so kind of to conclude then, so security is a system, so you need to think and protect all elements of the system. The system can include people, PCs, servers, routers, switches, firewalls, cables, SCADA, embedded systems, IoT, software policies, etc. So it's a lot of things, and all of it has to be looked at carefully. What does secure mean? What does the system is secure mean? A statement like that is meaningless. So you need to have some kind of way of measuring things, parameters and metrics. Metrics to assess security and risk are needed, right? And how do you do that? So that's a challenge, actually, right? So if you have those, let me know. but basically you have to decide what to protect against whom. Remember this again, the risk and control matrix that we talked about from 350. And these are mission dependent and depend on the organization that you have. All right, great. So you don't just basically, think about the axioms, etc. All right, so that's great. That's good. I think hopefully that's a good motivation for what the class kind of is about, some of the ideas. Are there any questions before we move on to the next topic? No questions. All right, great. So now, I think you are starting to get the idea, right, of what we will be doing. So now we're going to get into the specifics. Go back to table of contents. So we've covered this module now. I'm done with that. All right. So now let's take a look at this one. So this is Scapy.
I can't see your screen.
Oh, I'm fine. All right, so we kind of laid out the motivation for this. Okay, we talked about the big picture. We talked about the course. We have this ecosystem, but as I said, going back to this idea, if you're a marine biologist, you study the ocean, right? So you go, you learn how to become a scuba diver, and you jump in there, and you're going to analyze the life, I guess, wildlife in the ocean. Similar here, since we're talking about all these things with the network, etc. But at the end of the day, what the firewall is doing, what the router is doing, what the hosts are doing is they're dealing with these packets, right? Based on IP addresses and all of that, right? You have network IDs, those are IP addresses. Right? You talk about ports, what is that? Those are protocols, right? So you have, maybe it says TCP traffic. Is it ICMP traffic? All that stuff. So we need to have some way of dealing with network packets that's efficient for our purposes, instead of just having to rely on a GUI thing like Wireshark. Although I would recommend actually that you use Wireshark alongside everything. It will be helpful to sometimes. You won't understand what's going on, but then if you put Wireshark on, you'll see, oh, okay, wait, I see some packets here. That makes sense. So certainly for this course, Wireshark is a good tool to kind of have there. Okay. Yeah. All right. So let's take a look at this document. So what we're going to look at today in the rest of the time we have is this idea of Scapy. So I provided a document here. And you can see there, we'll go over this document before we even try to solve any labs or anything like that, any problems. We're just going to practice with Scapy a little bit. So I'm going to go ahead and just do a simple exercise. So let me. Oh, yeah. So we're going to start our VM actually. So I'm sure all of you're all familiar with this. But I guess I'll repeat it just briefly. You need a VM, at least for the first couple of labs. So just get the CVM. This is, you go here, and then you can install VirtualBox. And you should download from Lab Setup. And then you can pick Ubuntu 2004, sorry. And from one of these links. Download it. It should download like a zip file. If you need instructions on how to set it up, I haven't added the link here yet, but I have another link. You shouldn't really be using 1604 anymore, because it's gonna be phased out eventually. Okay, try to make the change. Yeah. Eventually, we will probably need to, as I said, convert that VM to the VMware version of it, just so that we can use VMware may have a few tools that we need. So as I said, if you don't know how to create the VM from that link, you can, I'm going to add a new link, but I'll just show you. I have it here. There, so install CVM on VirtualBox. So you can just click on this link and then it'll provide all the instructions, hopefully, that you need to create the 2004 VM in case you haven't created it yet. Okay, guys, is this clear? Are there any questions about this?
No questions.
So just create it, please. All right, so now that we have done that, let's go ahead and I'm going to and then I'm going to start the virtual machine. Let me, all right, there we are. So I'm sharing, you should be seeing the my VM starting up, hopefully.
Yep.
Let me just log in. All right, guys. So let's sit down a bit. All right. So the advantage, as you know, of using the VM here is that it has all the software that we need. Okay. All right, so the advantage of as I said, of using the CVM is that we have the software already installed on here and some of the configurations. So let's go ahead and start Scapy. Now, Scapy is already installed. However, if you had to install it, let's say that you're building your own machine, you would probably have to type something like sudo app, apt-get or app install Python Scapy, like that. Okay. So, you know, I already have it, so I'm not going to install it. But basically, it is a library for Python. So here then, if I want to just, now I can call it from Python, like a Python script, but I can also do just go into Scapy. So I can do sudo Scapy. You see that? Welcome to Scapy. Scapy, all right. And then basically you can see that the terminal has now changed to this 3 greater than symbol prompt. Okay. So if you want to just list things that are available for Scapy, you can do something like that. A lot of this, you know, you see like the SIGB and everything like that. So it's very much a network sniffer and spoofing tool, I guess. Yes. So it's great. It's a great tool for dealing with things that have to do with the network. So you can take a look at everything that it handles here. Obviously, we won't be looking at all of this, but what the great thing about this is it will allow us to deal with all kinds of packets under protocols, sniff radius, everything in the network that is relevant to our interests. So actually, RIP protocols, RSA, cryptography, different kinds of protocols here. Right, you can see that. Okay, so I'm just kind of going through this slowly, but it's a great tool for research, etc., for developing network applications, whether on the attack side, although I assume you guys are not attacking anything, and from the defense side as well. IPv6 is there, ICMP protocols, which we will be playing with a lot this semester. So as you can see, it's an extensive list, DNS services, DHCP, and so on, right? So we've got a lot there that we can play with. All right, so that's kind of the first part of it. As I said, later on, we'll just bring Scapy into Python. So I'll do, today I'm just doing a short introduction to this one, but just to kind of illustrate how this would work. So let's do the first thing. So, basically, let's just use Scapy as a type of a TCP dump, basically a sniffer, sniff the network traffic, right? So how do we do that? So we're going to exit out of here, actually. Clear. And then now I'm going to do, just ifconfig. So usually you have to get the interface of your network card, right? So you saw me also do something. I'll show you in a sec, but I need to find. So what's the interface here of interest? The network interface? That's right. Very good. So we need to grab that interface. So ENP0S3 will be the interface in question that we need to grab, and then we're just gonna run a Lambda function to kind of really quickly sniff some traffic. Okay. And again, I'm just showing very quickly kind of a rough way of illustrating. Now, notice another thing I did here. Pseudoscapy. I run pseudoscapy because I'm going to be grabbing the network interfaces, and that should not really be allowed, right? Because we are actually going to make this machine generate any packet that we want, and so obviously that should require the network privilege. So now let's say that I'm in Scapy now, and I want to run the sniff program. So I'm going to do sniff here. You can see it's very straightforward. I'm going to specify the interface. So I think it was called, what was it? ENP. What was it? Is it ENP0S3? I think that's what it is. I think that was the name. All right. And then just tell it here, we can specify what we want to do with the traffic in a very quick way. So we'll come back to this. So there's something called Lambda functions that allow us to really quickly prototype simple functions. So in this case, the input is X. And all we want is, because it's an object grabbed by Scapy, it's an object that can be shown. So we're going to call show like that. Do you see that, guys? All right. And so now if I hit enter here, notice that the terminal is just hanging, right? So that basically means that I've converted this library, our Python library that we will use later on in our Python scripts, into a sniffer. All right, so now I want to see some network packets over here. So a very easy way of generating some network packets without running like ping or anything is just open the browser, right? So when you open the browser, it should generate some packets. And there you can see them, right? So there are the packets. There you saw some DNS resolution there, and so on, right? Some TCP packets. Notice it's got a lot of interesting information about source port, destination port, sequence numbers, ACK numbers, all these flags, etc. And so this is going to be the information in question that we are going to have to process. Okay, so that's why we are going to need these devices. Does this make sense, guys? Is this clear? Okay, great. So hopefully you're following along. Great. So that's really all I want to. I'm going to kill this. And I'm going to close. Yeah. So all I want is, for you guys to kind of get the feeling, get the feel for this, right? So you can see a lot of data was printed out, right? Way too much data, in fact. So this is not very helpful. We have to find better ways of processing the data. The great thing about this is we will be able to do that now in code, right? So we'll be able to write our own programs, etc., so that we can build, either attacks or defenses. And we just have to think, what family of attacks do we want to do, and then craft the packets accordingly. Or if we're on the defense side, we also want to do that. So on Thursday, I'm going to do more examples of Scapy, just kind of introducing this. We will also start introducing some Pythons, how to integrate it with Python. So as I said, just this week, I'm not really like assigning a network security problem per se. We're just going to familiarize ourselves with Scapy. So that's really my goal, is that you feel a little bit more comfortable with it. And then after that, because some of the problems are a little bit challenging, so we will want to have a good, clear idea first of Scapy. So I'll generate some general coding examples, etc. And so that's the plan. So the plan for today was really just to kind of discuss, as I said, the administrative, discuss the class, the motivate the class, the objectives, and then really introduce just Scapy really quickly. If you don't have your VM ready, just make sure you have it for Thursday. And then on Thursday, I'm going to stop sharing this. Yeah. So if I go here, we're going to go back to the table of contents. So today we covered this one. No, sorry, not that. Security axioms. And I kind of started with just this document, right? Which is basically us. You can see here, I have the commands, at least some of the commands, and some scripting problems. And then, of course, there will be some things to look at. Just to play around with Scapy. You'll have a homework, obviously. But this is just really to familiarize ourselves with, how to deal with network packets. And then after that, we'll start getting into the more advanced things. So after we practice a little bit with Scapy, we're just going to get into the sniffing problems, of which, we'll be doing sometimes, just because Scapy is built on top of C++. It's built on top of the libpcap library. You know, we'll do a C++, although it's pretty easy, and then a Python, a pure Python sniffing set of problems, and so on. Okay, guys. All right, so that's basically all I have for today. If you have any questions, I'll stay for a few minutes to answer your questions. Otherwise, I will stop the recording right now, and I will see you guys on Thursday.